Now I'll be discussing some important locus, and the first one is mod of z minus z1 upon z minus z2, it is equal to k. Now we already know that if this k is equal to 1, then it will represent perpendicular bisector of z1 and z2, and if this k is unequal to 1, then in that case it will represent a circle provided coefficient of z in the numerator and denominator it must be 1. Now say for example we need to find locus of z such that z minus 5 iota upon z plus 5 iota it is equal to 1. Now coefficient of z here is 1 and the value of k is 1. So that means this z, it will be perpendicular bisector of 5 iota and minus 5 iota. Now perpendicular bisector of 5 iota and minus 5 iota is nothing but real axis. So this z, it lies on real axis. Another example could be this z plus iota upon z minus iota equals 2. Now in this case value of k is 2. That means this z, it will lie on a circle. Now there could be cases where we have this 3z plus 1 upon 2z minus iota equals 1.5. Now here coefficient of z is not 1. So what we'll do is we'll take 3 and 2 common from numerator and denominator. So we can write 3 by 2 and then now we'll have mod of z plus 1 by 3 upon z minus iota by 2 and it will be equal to 1.5. So this 1.5 and 1.5 will cancel. Now we can write mod of z plus 1 by 3 upon z minus iota by 2 is equal to 1, and since coefficient of z in the numerator and denominator is 1 and this right hand side is 1, so this z, it will lie on a straight line. So locus of z is the straight line which is perpendicular bisector of iota by 2 and minus 1 by 3. Now this second important locus, again we have discussed it in circle, and it is mod of z minus z0 equals r, mod of z minus z0 is less than equal to r, and mod of z minus z0 greater than or equal to r. In the first case, it will represent points on the circle with center z0 and radius r. In the second case, it will represent points on and inside the circle with center at z0 and radius r. And for this third case, it will represent points on and outside the circle with center z0 and radius r. Now we have a strict inequality, say mod of z minus z0 will be less than r, then it will be simply points lying inside the circle and not on the circle. So in that case, we'll draw this circle as a dotted circle. So it will be simply points lying inside the circle with center z0 and radius r. And in the same way, we can write it for mod of z minus z0 is greater than r. So again, we won't include points on the circle. So it will be this dotted circle, center z0, radius r, and it will be simply points lying outside this circle. So that's our second important locus. Now this third important locus is argument of z minus z1 upon z minus z2, it is equal to alpha. So if alpha is 0 or pi, then z lies on a straight line. Now if we examine it more closely, then suppose we have 2 points, say Z1 and Z2, and we take this point in between this line segment AB, then angle between this vector which is Z minus Z1 and this vector which is Z minus Z2 will be pi. So if we write argument of Z minus Z1 upon Z minus Z2, it is pi, then this Z, it will lie on line segment AB. So it will represent all the points which lies between A and B. Now if Z lies outside AB, now say Z is here, then this is Z minus Z1 and this is Z minus Z2. So that means if argument of Z minus Z1 upon Z minus Z2, it is equal to 0, then Z will lie on this line AB except for the points lying between A and B. Even if we take this Z here, then again this is Z minus Z1 and Z minus Z2. So if it is pi, it will represent all the points in between AB, and if it is equal to 0, then it will represent all the points on this line except the points between A and B. Now the second case, when argument of Z minus Z1 upon Z minus Z2 is plus or minus pi by 2. That means angle between AP and BP is always 90 degrees. So if we take this circle whose diameter is AB, and this is Z1 and this is Z2. Now we take any point on the circle, say Z. Now this is Z minus Z1 and this is Z minus Z2. Using rotation of vectors, we can say we have rotated AP to form BP. We can write Z minus Z2 upon Z minus Z1 will be equal to AP upon BP into e to the power iota pi by 2. That is argument of Z minus Z2 upon Z minus Z1 will be pi by 2. Now if we take this point Z here, then this is Z minus Z1 and now this is Z minus Z2. Now we have rotated Z minus Z2 to form Z minus Z1. In this case, argument of Z minus Z1 upon Z minus Z2 will be pi by 2, or we can write argument of Z minus Z2 upon Z minus Z1 will be minus pi by 2. So if we take only pi by 2, then it will represent this semicircle which lies below AB. And if we take minus pi by 2, if we take this minus sign here, then it will represent the semicircle which lies above AB. And if we take both plus or minus pi by 2, then in that case it will represent this circle. And third one is obviously for any general angle, which is argument of Z minus Z1 upon Z minus Z2, it is equal to alpha. So in that case it will represent portion of a circle having chord Z1 Z2 where angle in the segment is alpha. So this third case will represent portion of a circle and not the complete circle. Now the fourth locus is in terms of argument. So suppose you have argument of Z and say this is alpha. So that means we are talking about all the complex numbers z having argument alpha. So what we'll do is we'll draw this line making an angle alpha with positive real axis. So any point on this ray except 0, it will have its argument as alpha. So argument z equals to alpha will represent this ray passing through origin at an angle alpha moving away from it. Now more general case will be argument of z minus z naught equals alpha. In this case what we'll do is we'll first locate this z naught. So suppose this point is z naught, then angle of z from z naught is alpha. So all we need to do is we just need to draw a ray from z naught at an angle alpha with this horizontal line. So this is when argument of z minus z naught is alpha. Now we have any general case, say mod of argument of z plus 1 is less than or equal to pi by 4. Now we can write this as minus pi by 4 will be less than or equal to argument of z plus 1 will be less than or equal to pi by 4. Now standard form is z minus z naught. So we have to write it as minus pi by 4 is less than equal to argument of z minus of minus 1 is less than or equal to pi by 4. So we have to draw the angles from this minus 1. So first we'll locate minus 1. So we have this Argand plane and this point is minus 1. Now we have to find all the complex number z such that its angle will lie between minus pi by 4 and plus pi by 4. So we'll draw these two lines, one at pi by 4 and one at minus pi by 4. So this z, it will lie on this region in between these two lines. So that's our fourth locus. When we have this straight line passing through 2 points A and B, where A is Z1 and B is Z2. Now we'll consider two cases when Z lies between AB. Now in this case, PA plus PB, it must be equal to AB. So if we have any condition where we are given that mod of Z minus Z1 plus mod of Z minus Z2, it is equal to Z1 minus Z2, then this Z, it will lie on line segment AB. So it won't represent this complete line, it will just represent this line segment AB. Now another way to write it is in terms of its argument. Now this is Z minus Z1 and this is Z minus Z2. So if we write argument of Z minus Z1 upon Z minus Z2, it is pi. Then also this Z, it will lie on this line segment AB. Now this second case, when Z lies on line passing through AB except points between A and B. So now suppose we have this Z here. Now this is AP and this is BP. So if the condition is AP minus BP mod of it and it is equal to AB, then this Z will lie on this line AB except for the points between A and B. So we can write this condition as mod of Z minus Z1 minus mod of Z minus Z2, and it is equal to mod of Z1 minus Z2. In that case, this Z, it will lie on these two rays, one through this B and the other through this point A. Another way to write it is in terms of argument. Argument of z minus z1 upon z minus z2, it is 0. So that's our fifth locus. Now here the question is, the complex number z satisfying mod of z minus 2 minus iota plus z minus 2 minus iota, it is equal to mod of minus 2 minus iota and then minus 2 minus iota, which is of the form mod of z minus z1 plus mod of z minus z2 is equal to mod of z1 minus z2. That means in this case z will lie on line segment joining z1 and z2, which is minus 2 minus iota and 2 minus iota. So we'll draw this first locus. Now this point is 2 minus iota and this point is minus 2 minus iota, and it consists of all the points on this line, which is y equals minus 1. Now this second locus is argument of z minus 2 minus 2 iota, it lies between 0 and pi by 4. So first we locate minus 2 and minus 2 iota. So this point is minus 2 minus 2 iota, and here this argument, it should lie between 0 and pi by 4. So we are talking about all the points inside this angle. And the next one is argument of z minus 2 minus 2 iota, it should lie between pi and 3 pi by 4. So here we have this point which is 2 minus 2 iota, and here this angle, it lies between 3 pi by 4. Now the complex number z, which is common to all the three regions, is this length. Now this is 1 unit and this angle is 45 degrees. That means this is 1 and this is also 1. So it will be line segment of length k, then the value of k is simply 2. Now here the question is, this shaded region where p is minus 1 comma 0, q is minus 1 plus root 2 comma root 2, and r is minus 1 plus root 2 and minus root 2, and s is this point 1 comma 0. It is represented by which of the following conditions? Now first we look at this circle. So all these points, they lie outside this circle. So the one condition that we have here is mod of z plus 1 and its radius is 2 units. It should be greater than 2. So mod of z plus 1, it is greater than 2. Now this point is minus 1 comma 0 and this point is minus 1 plus root 2 and this is root 2. So this is root 2 and this is also root 2. That means this angle is pi by 4. That means we need all the complex numbers which lie inside these two angles. So this complex number is given by argument of z minus z0, and z0 here is minus 1. So argument of z plus 1, it should be greater than or equal to minus pi by 4 but less than or equal to pi by 4. Or we can write mod of argument of z plus 1, it is less than or equal to pi by 4. And that is the answer to this question. Now the question is, interpret the following locus. Now this A is this circle whose center is at 2 iota. So we have center at 2 iota. Then we have two circles, one of radius 1 unit and the other one of radius 3 units. Now it says this mod of z minus 2 iota, it should lie between 1 and 3. So we are talking about all the points in between these two circles. Now this second locus is real part of z plus 2 iota, iota z plus 2, it is less than or equal to 4. Now z plus 2 iota will be x plus y plus 2 iota, and it will be iota x plus 2 minus y, and we can rationalize it as minus iota x plus 2 minus y upon minus iota x plus 2 minus y. Now we can multiply it. We'll get minus iota x square and then plus x into y plus 2 plus x into 2 minus y plus 4 minus y square iota upon x square plus 2 minus y whole square. Now we need its real part. Its real part will be 4x upon x square plus y square plus 4 minus 4y. It is less than or equal to 4. We'll cancel this 4 with 4. We can write this equation as x square plus y square minus x minus 4y plus 4. It is greater than or equal to 0. So this equation will represent points lying on or outside the circle whose center is at 1, 2 and whose radius is 1 by 2. So this is 1 by 2, 2. This is the circle. We are talking about all the points lying outside this circle. Now this third locus is argument of z plus iota upon z minus iota. It is pi by 2. Now we know that it represents a semicircle whose endpoints of diameter are minus iota and plus iota. So we'll draw this circle. Endpoints of diameter are iota and minus iota. Now it is not plus minus pi by 2. So that means it is not going to represent this complete circle, but it is going to represent a semicircle. Now which one? On the left or on the right? Now if we take this point z here, then this is z plus iota and this is z minus iota, and this angle is 90 degrees when the rotation is in anti-clockwise direction. So from this we can write argument of z plus iota upon z minus iota. It is pi by 2. So that means we are talking about all the points on this semicircle which lie on first and fourth quadrant. Now this D is argument of z minus a equals pi by 3. Now it is given that a is 3 plus 4 iota. So we write this point which is a, and it is 3 plus 4 iota. Now it says argument of z minus a is pi by 3. So we have located this a, and then from this a we'll draw a line at an angle pi by 3. So locus of z now will be this ray starting from this point a, where a is not included, and it stretches and it goes all the way up to infinity. Now here the question is the complex number where the curves argument of z minus 3 iota equals 3 pi by 4 and argument of 2z plus 1 minus 2 iota equals minus pi by 4. Now for this first one, we know that it is this ray which starts from 3 iota and then it'll go in the direction where this line, it makes an angle 3 pi by 4 with the positive real axis. Now for the second one, we can write argument of 2 plus argument of z plus 1 by 2 minus iota, it is minus pi by 4. Now argument of real number with positive real part is 0. So we can write this is argument of z minus 1 by 2 plus iota, it is equal to minus pi by 4. Now we look at this point, minus 1 by 2 plus iota. So this point, it will be minus 1 by 2 plus iota, and here it makes an angle pi by 4. Now these two curves, they don't intersect at all. So the points where they intersect is none. Now here the question is, the locus represented by this equation mod of z minus 1 plus mod of z plus 1 equals 2 is. Now we can write this as mod of z minus 1 plus mod of z minus 1, and this 2 is 1 minus of minus 1. So we get this as mod of z minus z1 plus mod of z minus z2, it is equal to mod of z1 minus z2. That means this z, it will lie on this line segment joining z1 and z2. Now in this case, one point is minus 1 and the other point is 1. So this locus, it will represent all the points between minus 1 and 1, including both, and that's your option D. Now this sixth locus is in terms of conic sections. So suppose we have 2 points A and B such that A is given by Z1 and P is given by Z2, and suppose there is a complex number, say P, which is given by Z. Now if we are given that mod of Z minus Z1 plus mod of Z minus Z2, and it is equal to some positive real number K, then if this K is mod of Z1 minus Z2, then basically locus of Z is this line segment AB. And if this K is greater than mod of Z1 minus Z2, then in that case we can write this as PA plus PB, it is equal to some constant K, which is focal property of ellipse. We need this condition because this K, in that case, will represent 2A, and mod of Z1 minus Z2, it will be distance between two focus, and it is 2AE. And we know that in case of an ellipse, value of E is always less than 1. So if K is greater than mod of Z1 minus Z2, then this Z, it will lie on this ellipse whose focus is at Z1 and Z2, and length of whose major axis will be equal to K. And if this K is less than mod of Z1 minus Z2, then it doesn't represent any locus. Now the seventh one is, if we have this condition that mod of Z minus Z1 minus mod of Z minus Z2 whole mod, and it is equal to K. Now this first case, when this K is equal to mod of Z1 minus Z2, we have already established that AP minus BP, it is equal to AB, then Z lies on straight line AB except for points lying between A and B. Now if K is unequal to mod of Z1 minus Z2, then we'll have this condition that mod of AP minus BP, it is equal to K, which is focal property of hyperbola. Now distance between focus is given by Z1 minus Z2, which is twice AE, and this K, it is 2A. And since for hyperbola E is greater than 1, then twice AE, it must be K. So in this case, this K, it must be less than mod of Z1 minus Z2. And if K is greater than mod of Z1 minus Z2, then again it won't represent any locus. Now here the question is, if A is greater than 0 and if the equation represents an ellipse, then A lies in. Now we know that the equation mod of Z minus Z1 plus mod of Z minus Z2 equals K. It will represent an ellipse if K is greater than mod of Z1 minus Z2. Now in this case, value of K is 3. So the condition that we'll have is 3 must be greater than mod of Z1 minus Z2. Now Z1 is A square and Z2 is 2A. So we'll get A square minus 2A. Now when mod X is less than A, then X will lie between minus A and plus A. So from here we can write A square minus 2A will be greater than minus 3 but less than 3. Now if we solve this, we can write A square minus 2A plus 3, it is greater than 0. Now this is true for all A belongs to R. So this is always true. Now we have to solve the second part, which is A square minus 2A minus 3 is less than 0. So we can write A minus 3, A plus 1, it is less than 0. So we'll get minus 1 and 3. So this is plus, minus and plus. So the value of A must lie between minus 1 and 3. But it is given that A is greater than 0. So the value of A, it must lie between 0 and 3. And that's your option C. Now the question is, let eccentricity of ellipse with foci Z1 and Z2 be 1 by 3. So we have this ellipse whose foci are Z1 and Z2, and here the value of E is 1 by 3. Now it says mod of Z1 minus Z2 is 5. Now we know that mod of Z1 minus Z2 is distance between its focus, and distance between its focus is 2AE. So we can write 2AE equals 5. Now value of E is 3. So value of A is 15 by 2. Now we need to find maximum possible value of mod Z minus Z1. Now Z, it will lie on this ellipse. Now we know that this distance will be maximum when it will lie here. Now this is A and this is AE. So maximum value of this modulus will be simply A into 1 plus E. Now A is 15 by 2 and 1 plus E is 4 by 3. So this is 5 into 2 and it will be simply 10. So maximum possible value of mod Z minus Z1 will be 10. Here the question is, if Z be complex number on the complex plane satisfying mod Z minus 0 minus mod Z minus 6 plus 8 iota equals 10, then Z represents what? Now here we can also write this as Z minus 0 minus Z minus 6 plus 8 iota, and it is equal to mod of 6 plus 8 iota minus 0. Now this is PA minus PB and it is equal to AB. Now if PA minus PB it is equal to AB, then this P, it lies on this ray which is to the right of B. The option which is little close to that is a line, but basically it's not a line segment. Now here the question is, match the equation on the left with the curve they represent on the right. Now this first one, which is A, it is mod of z minus 3 plus mod of z minus iota equals 10. Now here the value of k is 10, and if we write mod of z1 minus z2, it will be simply 3 minus iota, and which is under root 10. Now in this question, k is greater than mod of z1 minus z2. That means this equation will represent an ellipse. So this A, it matches with S. So this is S. Now for the second one, we are given that 2z minus 3 upon z minus iota equals 2. Now coefficient of z, it must be 1. So we'll take this 2 common. So we can write mod of z minus 3 by 2 upon z minus iota, it is 1. And if mod of z minus z1 upon z minus z2 is 1, then this z will lie on a straight line. So this B, it matches with R. Now this third one is z square plus z bar square, it is equal to 5. Now this is x plus iota y square, and here will be x minus iota y square, and it is equal to 5. So we'll get this as 2 x square minus y square equals 5. So it will be x square minus y square equals 5 by 2, which is nothing but a hyperbola, and that's your option Q. So the C, it matches with Q. Now what about D? Now D is mod of z minus z1 upon mod of z minus z2 equals 3. Now since it is unequal to 1, that means this locus is a circle. So this D, it matches with P. And that is the answer to this question. Let A, B, C be three set of complex number defined below. Now the first one is mod of z plus 1. It is less than or equal to 2 plus real part of z. Now this is under root of x plus 1 whole square plus y square, and will be less than or equal to 2 plus x. Now clearly x is greater than or equal to minus 2, and then if we square, we get x square plus 1 plus 2x plus y square, it is less than or equal to 4 plus x square plus 4x. Now here x square will cancel. Now we can write this as y square, it is less than or equal to 2x plus 3, or y square is less than or equal to 2 into x plus 3 by 2. I will mark a point at minus 3 by 2 and will form a parabola opening right. So we have this parabola. Now if you put x and y as 0, it satisfies this inequality. That means it will have all the points lying inside this parabola. Now the second locus is mod of z minus 1, it is greater than or equal to 1. So we have this one here, and then we have this circle. So we have all the points which lie outside this circle. And finally, we'll have this last result where mod of z minus 1, it is greater than or equal to mod of z plus 1, that is x square plus 1 minus 2x plus y square, it is greater than or equal to x square plus 1 plus 2x plus y square. Now x square y square 1 will cancel. We'll get this as x is less than or equal to 0. That means all the points which lie in second or third quadrant. So we are talking about this region. So the region which is common to all the three conditions is this region. Now what are the possible integral coordinates in this region? Now one of the possibility is when the value of x is minus 1. Now, if the value of x is -1, value of y is plus or -1. So we'll have 2 points here, one at -1, 1 and the other one at -1, -1. And we also have this third point which is -1, 0. So we have 3 points, -1, 1, -1, -1 and then -1, 0. Now what are the points with integral coordinates? This is one point which is 0, 0, and then we'll have this point which is 0, 1 and 0, -1. So we'll have 3 more points, 0, 0, 0, 1 and 0, -1. So the number of points having integral coordinates in this region is simply 6. Now this is an interesting question involving complex numbers and parabola. It says, let Z be a complex number of maximum amplitude satisfying mod of Z minus 3 is equal to real part of Z. Then we need to find the value of mod Z minus 3. So first we'll simplify this equation. So what I'll do is I'll let Z as x plus iota y. So then we can write x minus 3 plus iota y is equal to real part of z, which is x. So we'll find its magnitude and we'll square it. So we'll write x minus 3 square plus y square is equal to x square. So we'll get x square plus 9 minus 6x plus y square is equal to x square, which will get cancelled. So we'll write y square equals 6x minus 9, or y square is 6 and then x minus 3 by 2. If we'll compare it with the standard parabola, then it will be y square equals 4a capital X. Now in this case, value of a is simply 3 by 2. So we have this parabola whose vertex is at 3 by 2, 0. So we'll draw this parabola. Now on this parabola, we need a point Z having maximum amplitude. We know that amplitude is nothing but angle that a point makes with positive real axis. So if we look at these points, then we know that this angle, it is increasing. Then we'll have one point where this argument will be maximum. So this argument will be maximum at a point P at which tangent drawn will pass through origin. So we'll need to find coordinate of this point P. So once we have equation of this parabola, we can write equation of tangent as y equals m. Now in place of x, we can write x minus 3 by 2 and then plus a by m. Now a in this case is 3, so it will be 3 by 2m. We need that tangent which passes through origin. So we'll put x and y as 0. So we'll put x and y as 0. We'll get 0 equals minus 3m by 2 plus 3 by 2m. So from here we'll get the value of m as plus or minus 1. Now since we need z of maximum amplitude, we'll take m as plus 1. So for this z, value of m is plus 1. Now once we have this slope, we can write this point of contact. So this point of contact will be x equals a by m square. Now x in this case is x minus 3 by 2 and it should be equal to a by m square and then y equals 2a by m. Now we'll put the value of a and m. Now a is 3 by 2 and m is 1. So we'll get x as 3 and y as 3. So this point P, its coordinate will be 3, 3 and this z is 3 plus 3 iota. Now we'll need to find the value of mod z minus 3. So mod z minus 3, it will simply be mod of 3 iota, and mod of 3 iota is 3. So answer to this question is 3. Now here the question is, let z be a complex number satisfying this equation, which is mod of z minus 2 is equal to real part of z. Then we'll need to find minimum value of mod z minus 4. Now we are given that mod of z minus 2 is equal to real part of z. So we'll take z as x plus iota y. Now we can write this as mod of x minus 2 plus iota y, and real part of z, it is simply x. So it will be under root of x minus 2 square plus y square equals x. So we can write x square plus 4 minus 4x plus y square equals x square. So we write this equation as y square equals 4 x minus 1. So basically z lies on this parabola whose focus is at 1, 0. So we'll draw this parabola. It says we'll need to find minimum value of mod z minus 4. So in complex numbers, we know that modulus is basically distance between 2 points. So one of the point is z, which lies on this parabola, and another point is 4, which lies on axis of this parabola. So we'll need to find the minimum value of this distance between a point on parabola and this fixed point. Now we have already studied that minimum distance will occur along a normal which will pass through this point. So what we'll do is, for this parabola, we'll write equation of normal. So for this parabola, equation of normal will be y equals m. Now in place of x, we'll write x minus 1 minus am cube. A in this case is 1. So it'll be m cube minus 2m. We need that normal which passes through this point 4, 0. So we'll put y as 0 and x as 4. So it'll be 0. And then 3m minus m cube minus 2m. So it'll be m cube minus m equals to 0. We'll get 3 values of m. Either m is 0 or m is 1 or m is minus 1. Now 3 normals can be drawn from this point 4, 0. We'll need to find shortest distance from this parabola. So we'll write foot of all the 3 normals. So we know that foot of normals is given by am square minus 2am for a parabola which is y square equals 4ax. But we have a parabola which is y square equals 4x minus 1. So in this case, foot of normal will be given by 1 plus am square minus 2am. Now for this parabola, value of a is 1. So now we'll start putting the value of a and we'll start putting in the value of m. So we'll take m as 0. We'll get this point as, say, a, and it will be simply 1, 0. If we'll put m as 1, then we'll get this point, say, b. So a is 1 and m is 1. So it will be 2, minus 2. So b is 2, minus 2. And then we'll find this point which is c when the value of m is minus 1. So we'll put m as minus 1. We'll get this point c as 2, 2. So this point, it will be 2, 2. Now we'll find all these 3 distances and then we'll see which is the minimum distance, and there will be the minimum value of mod z minus 4. So we'll find this AP. So this AP is simply 4 minus 1 and that is 3. And from symmetry we can say that BP must be equal to CP, and this value, it will be under root of 2 square plus 2 square
and that should be 2 root 2. So the minimum value of mod z minus 4 will be simply 2 root 2, and that is the answer to this question. Now this third question is, we are given a set which is sigma, which is set of all complex numbers x plus iota y such that mod y is less than or equal to 1, and then we are given this function which is fz, and that is z square plus 2. Now it says draw a sketch of f sigma which is fz for all z belongs to sigma. So that means for all the complex numbers z present in this set, we need to draw the sketch of fz. Now first we'll look at input values. Now this sigma, it contains all the values of x and y such that mod y is less than or equal to 1. So when mod y is less than or equal to 1, it means value of y should lie between -1 and +1. So its domain space is within these two lines, which are y equals 1 and y equals -1. So we are talking about all the points in this shaded region. Now we'll put the points from domain in this function, then it will transform into an output space. Suppose u plus iota v. So we'll write this fz as sum u plus iota v, and it is z square. Z is x plus iota y whole square plus 2. So we'll write this as u plus iota v, and it'll be x square minus y square plus 2 xy iota. Now we need to draw sketch of u and v. Now comparing real and imaginary part, we can write u as x square minus y square plus 2, and we'll write v as 2xy. Now the condition given in the question is this mod of y is less than or equal to 1. Now what we'll do is we'll begin with the boundary cases. The boundary cases which are when the value of y is 1, when the value of y is -1, also when the value of y is 0. So when the value of y is 1, in that case u will be x square plus 1, and v, it will be 2x. So we can write this x as v by 2. So we'll write this as v square by 4 plus 1. So we'll get this parabola which is v square equals 4u minus 1. So we'll take this boundary condition when the value of y is 1. We'll end up getting this parabola which is 4u minus 1. Now we'll take y as -1. If we'll take y as -1, again we'll get u as x square plus 1, and v is minus 2x. Again we'll replace x with minus v by 2. So we'll get u equals v square by 4 plus 1. So again we'll get v square equals 4u minus 1. So that is for both the boundary values 1 and -1, we are getting the same parabola which is v square equals 4u minus 1. Now if we'll put y as 0, in that case we'll get u as x square plus 2 and v as 0. In that case we'll get a ray lying on x-axis and which is greater than or equal to 2. Its y coordinate will be 0. Now what we'll do is we'll plot these three sketches. Now this is u and this is v. Now this is y square equals 4ax. So it represents a parabola opening rightwards and shifted 1 units to the right. So we can draw this parabola as v square equals 4 into u minus 1. Now second one, it's again the same parabola. And this third one is u equals x square plus 2. So in this case, u will be greater than or equal to 2 and v is 0. So I'll represent this ray starting from 2 and going towards infinity. So this is the sketch of boundary values. Now we need to find this complete region. Now we know that this u is x square minus y square plus 2 and v is 2xy. So if we'll square this second equation, we'll get v square equals 4x square y square. Now in the question it says mod of y is less than equal to 1, which simply means y square is less than equal to 1. So we can write v square is less than or equal to 4x square. Now from this first equation we can write y square, it is x square plus 2 minus u, and again it is less than or equal to 1. So from here we'll write x square is less than or equal to u minus 1. So now we have two inequality relationships, which is v square is less than equal to 4x square and x square is less than u minus 1. So from these two we'll get this condition, which is v square is less than or equal to 4 u minus 1. So that means for all the points in this input space, we are getting a condition where v square should be less than or equal to 4 u minus 1. So if we'll take any point, say origin, if we'll put v as 0 and u as 0, we'll get 0 is less than equal to minus 4, which is incorrect. So that means we are talking about region other than origin. So the sketch of output space is this parabola and points lying inside of this parabola. And that is the answer to this question.
Now here the question is, if R1 and R2 are the maximum and minimum distance of a points on the curve 10 z bar minus 3i z square minus z bar square minus 6 equals 0 from origin, find R1 plus R2. Now we'll take z as x plus iota y, then z bar is mod of z square, which is x square plus y square minus 3 iota. Now this is x plus iota y whole square minus x minus iota y whole square. So it will be simply 4xy iota and then minus 6 equals to 0. So this locus, it will be 10x square plus 10y square plus 12xy minus 6 equals to 0. And we can also write this as 5x square plus 5y square plus 6xy, and it is equal to 3, which is nothing but a central conic. So this equation, it represents an ellipse whose center is at origin. Now it says we need to find maximum and minimum distance of the points on this ellipse from center. So what we'll do is we'll say let any point which is at a distance r and at an angle theta can be expressed as r cos theta and r sin theta. So we'll put x as r cos theta and y as r sin theta. Then we'll get 5 r square and it'll be cos square theta plus sin square theta plus 6 r square sin theta cos theta, and it'll be equal to 3. Now cos square theta plus sin square theta is 1. 2 sin theta cos theta, it is sin 2 theta. So we can write r square as 3 upon 5 plus 3 sin 2 theta. Now we need to find maximum and minimum value of r. Now this r, it will be minimum when this denominator is maximum, and the maximum value of sin 2 theta is 1. So minimum value of r square will be 3 upon 5 plus 3, which is 8. So value of r minimum will be 1 by 2 root 3 by 2. Now we'll get this value maximum when denominator is minimum. Minimum value of sin 2 theta is minus 1. So here we'll get this value as 3 by 2. So maximum value of r, it will be under root 3 by 2. Now we need to find the value of r1 plus r2. So value of r1 plus r2, it will simply be 1 by 2 root 3 by 2 plus root 3 by 2. So it will be 3 by 2 under root 3 by 2. and that is the answer to this question. Now here the question is, for a complex number z, real z denotes the real part of z. Let S be a set of all complex numbers satisfying z to the power 4 minus mod of z to the power 4, and it is equal to 4 iota z square. We need to find the minimum possible value of mod of z1 minus z2 whole square, where z1 and z2, they belong to this set such that real part of z1 is positive and real part of z2 is negative. Now we know that mod of z square is nothing but z into z bar, and this is perhaps the most important property of complex numbers. So we'll write mod of z to the power 4 as z square and z bar square, and it'll be equal to 4 iota z square. Now we can take z square common, so we'll get z square minus z bar square equals 4 iota into z square. So one of the solution will be z equals 0, or we'll get z square minus z bar square, and it is equal to 4 iota. Now we can write this as z plus z bar upon 2 into z minus z bar upon 2 iota, and it is equal to 1. Now this is nothing but its real part x, and this is imaginary part y. So if z is x plus iota y, then this other condition, it represents a rectangular hyperbola xy equals 1. So this set S, it contains either this point 0, which is origin, or points on this rectangular hyperbola xy equals 1. Now we need to find minimum possible value of mod of z1 minus z2 square. Now we already know any modulus is nothing but distance between 2 points. So we need to find minimum possible distance between z1 and z2 such that real part of z1 is greater than 0 and real part of z2 is less than 0. So it simply means z1, it will lie on this branch of hyperbola, and z2, it will lie on the other branch of hyperbola. And we need to find 2 points z1 and z2 such that this distance z1 minus z2, it is minimum. We know that in any curve, minimum distance occur along a common normal, and which in the case of rectangular hyperbola, it will occur along this transverse axis. So if we choose z1 and z2 as vertices of this rectangular hyperbola, then this distance mod of z1 minus z2 will be minimum. Now we need to find z1 and z2. Now we know that transverse axis of rectangular hyperbola is y equals x. So we'll put y as x. We'll get this point as 1, 1 and this other point as minus 1, minus 1. So we'll find mod of z1 minus z2. Mod of z1 minus z2 will be under root of 2 square plus 2 square. So mod of z1 minus z2 whole square, and it'll be equal to 8. So minimum possible value of z1 minus z2 square will be 8, and that is the answer to this question. Now here the question is, we need to find what does these locus on the right represents. Now the first question is, the locus is the point h comma k for which this line touches the circle. Now we know that any point on this circle, we can write it as 2 cos theta and 2 sin theta. Now equation of tangent is given by t equals 0. So there will be 2x cos theta plus 2y sin theta, and it must be equal to 4. So this equation of tangent will be x cos theta plus y sin theta, and it is equal to 2. Now since this given line, it is tangent to this circle, then from here we can write h as cos theta upon 2 and k as sin theta upon 2. So from here we can write h square plus k square, it is 1 by 4. So this equation will be x square plus y square equals 1 by 4, which represents a circle. So this P, it matches with A. Now the second one is point Z in the complex plane satisfying mod of Z plus 2 minus mod of Z minus 2 equals plus or minus 3. Now here we have a point P whose complex number is Z, and then we have 2 points, say A and B.
A is minus 2 and B is plus 2. If we write this condition, we write this condition as PA minus PB is plus or minus 3, where the value of AB is 4. Now if we look at this condition is PA minus PB is equal to K, where K is 3 and it is less than AB. Now this is nothing but a focal property of hyperbola. This equation in Q is a hyperbola. So this Q, it matches with D. Now the third one is x is root 3 1 minus t square upon 1 plus t square and y is 2t upon 1 plus t square. We'll take t as tan theta. Then x will be root 3 and this is cos 2 theta and y will be sin 2 theta. Then we can write x square upon 3 plus y square, it is equal to 1, which is nothing but an ellipse. So this point R, it matches with C. Now point as is, eccentricity of the conic lies in the interval from 1 to infinite. So if it is 1, it represents a parabola, and if it is greater than 1, it represents a hyperbola. And the last one is point Z in the complex plane satisfying real part of Z plus 1 square, and it is equal to mod of Z square plus 1. Now it is x plus 1 plus iota y whole square, and it will be x square plus y square equals 1. Now it will be real part of x plus 1 whole square minus y square plus 2 x plus 1 into iota y, and this is x square plus y square equals 1. So real part here is x square plus 1 plus 2x minus y square, and it will be equal to x square plus y square plus 1. Now x square and 1 will cancel. So we'll get 2y square equals 2x, that is y square equals to x, which is a parabola. So this T, it matches with B. So options that we have is A, it matches with only P. B, it matches with S and T. C, it matches with R. And D matches with Q and S. And that is the answer to this question.